The purpose of this demonstration is to illustrate how people from a different background and different discipline can work together in a collaborative manner thanks to 3D experience. We're going to illustrate this with three engineers, one being our industrial designer. We're going to have our expert in manufacturing and our mechanical engineer. The idea is that our industrial designer is based, let's say for example, here in Munich with one of our German customers with this marketing team. Our manufacturing expert will be based in Geneva, where he has a global view of our production footprint throughout Europe. And our engineering expert, machinery expert, is based in France, where we have our team of our machinery center. The first thing we want to do is our industrial designer will go ahead and sketch what could be the modification of the pack. And what we see here is that it does very simple modification on a 3D model, and this 3D model is what's going to be exchanged with the other, what's going to be shared with the other engineers. So in other words, the 3D model is becoming our common language. So he's sending a note to his friend saying, okay, I am making this new sketch. Do we believe we can execute it here? So we start from this rough sketch. Now we're landing on the screen of the manufacturing expert, who has exactly the same model coming to him, and he's gonna first evaluate what kind of modification needs to be done. So in this case, on purpose, we chose very simple modification, but still it requires his expertise to estimate the kind of modification that we will have to do. So what we understand is that the cutout that have been designed will have an impact on this die cutting, which is what is pointing out here. But obviously the answer is yes, we can go ahead and make this modification as far as I'm concerned. And he's telling the rest of the team, yes, please let's proceed. At the same time, the mechanical engineer has also made his preliminary evaluation, saying that, okay, I probably need to modify this part of the machine where we have some lugs pushing the size of the carton. And the shape of the side of the carton having been modified, we'll probably need to modify the shape of this blue lug. So on the machinery side, we also basically have a go to proceed with the pack modifications. Now we're switching back to Munich, where our engineer, still in front of the customer, is basically doing the modification live. So he's making the modification directly on the 3D model taken from the central database. So we're going to make very simple or very basic modifications to follow the contour of the glass. So the cutouts will follow the contour of the glass. And as I said earlier, everything is made in 3D. So the shape that has been extracted from his preliminary design will be applied to the carton, to the flaps of the carton, and will just create the cutout as expected. So that's it for one side. And that's it for the other side. So basically now we have this new pack with the cutouts on both sides that we want to go explore more deeply throughout the complete supply chain. So he's saving the new pack in the database, and now he's asking obviously his colleagues to do the same kind of study, starting with the mechanical engineers. The model is already loaded in the PC of the mechanical engineer, and is loading also the new pack to replace the old pack. And obviously there is a clearance between the lug and the side of the carton as expected because we did this cutout. So we will analyze this clearance, which is what's happening here. We can see the clearance between the lug and the carton, and the system will automatically recalculate or regenerate the new lug based on this yellow curve, which is the one that had been created by the industrial designer initially. So the new lug with this additional light blue part is generated automatically. And from there, we will be able to run the machine and see that we have not forgotten anything in the design process. The packs go out of the machine flawlessly. The mechanical engineer basically confirmed that the work has been done on his side and we're switching to the converting world. In the converting world, as you can see, the modification has already been implemented, and basically we understand that it's going to be an easy modification to be done without any strong impact on the production lines. What we are doing now is to compare between all our printing press formats, what the different kind of die cut sheets we will have, and which ones are the most interesting cost-wise, where we use the most surface of the board. Next step is to make a quick palletization pattern and a quick CO2 footprint analysis to see how many trucks we need to have from the converted plant to our customers, and then do the same with the finished goods to determine how many trucks we need to put on the road to convey all the finished goods to the retailers. But the study from a manufacturing point of view is made also, and we basically have at this stage completed all the technical part of the study. So the next phase is now with the customer to have an understanding of the shelf impact of this new pack at the supermarket. Here we can see that we have a complete store shelf with many different packs, and we can very quickly understand how much space each pack uses, and specifically this one. We can work on the different planogram and find what the best arrangements are, and also have some sense of what the consumer experience is going to be when he takes the pack. So what he's going to see when he's coming in front of the store. The very last point for us, which is critical, is now to generate a report where all the things we've just done is recorded automatically, so that we can share it internally, but it can also be shared with our customers, and it's basically engraved for the next steps of the projects. So this quick Microsoft Word document recaps all the different steps that have been done in those 10 minutes.